What if you cannot run an A/B test? Can k-means clustering help your experiment? Today I'm going to show you how k-means clustering can help group your data, fix your experimental design, and create results that you can trust. My name is Matt, and I have years of experience planning, launching, and post-auditing field experiments, and most of them used k-means clustering. What is k-means clustering? K-means clustering is an unsupervised machine learning algorithm that looks at your data and separates it into similar clusters or groups. Let's take a very simple example. Imagine we have this group of points here and we want to be able to group them into different clusters. You can use k-means clustering to help us differentiate between this group of points and this other group of points. So what does this mean in real life? Well, these points could be different people. It could be different stores, it could be different airport routes, and k-means clustering will help us cluster them into similar groups. If you guys want more details on how this actually works behind the scenes on the stats side, let me know and I'll be happy to make a video on it. So how can we use k-means clustering to help us in our experimental design? Let's set up an example. Let's say you have 200 stores and you got a new product that you want to sell, a pair of headphones. And we want to know which packaging is going to sell the most, the black packaging, the white packaging, or the green one. In a perfect world, we could run an ABC test where a third of our customers would see the black packaging, another third would see the white, and then the last third would see the green. And you would want all of these customers to be randomly assigned. But we know that that's not really doable in practice. So maybe let's just take 66 of our stores, let's put the black one there, 66 other stores get the white, and 67 stores get the green. And then see which one does better. That could work, right? No. That doesn't work because maybe the 66 stores that have the black product, maybe they're in a higher income neighborhood and people are just more likely to spend. And the stores that have the green product are maybe in smaller stores with less customers seeing the product every day. So that doesn't work. This is where we can use our k-means clustering algorithm to group our stores into similar groups. Let's say we were interested in grouping these stores by 3 types of features, the size of the store, the average order value of our customers, and the number of customers that walk into the store every day. After doing the clustering, you might get 20 stores that have a very high average order value, but a small number of customers per day and a small store area. Then another group would have 100 stores with a small average order value, but the area of the store is really big and there's a lot of customers that enter every day. And then the third cluster could have 80 stores where the average order value is small and the area of the store is small, but you still get a lot of customers per day. That's what k-means clustering will help us do. Then for this experiment, what we can do is make sure that there's an even number of all of those different types of stores in our experiment groups. So group 1 will have a mix of all of those stores. Group 2 will have another fair mix of those, and group 3 as well. And then finally, one of the groups will get the black packaging, another group will get the white, and the last group will get the green. And the idea here is now you can accurately compare the outcomes from each of these stores, since we know that the groups of stores are very similar to each other. Now, let's analyze the results. Let's look at the revenue results before any of the packaging changes across each of the 3 groups. We would expect that the revenue results would be the same across each group, since we know that the groups are supposed to be even at this point. Then, let's see what happened once we changed the packaging. What you might see is that group 1 with the black packaging went up in revenue, while the other 2 actually went down. This is a pretty clear indication that our black packaging might be the best performer. Something we could do as a sanity check is also add in the last year revenue curve, just to see if there was any seasonal impact. And in this case, you see that there wasn't. So we're a lot more confident in being able to say that the black packaging really is the best performer. So k-means clustering does a really good job at kind of simulating an A/B test without it being a proper A/B test. The only thing is you need to make sure that you have a setup that works for k-means clustering. And what I mean by that is you need to have a pretty rich data set. You need to be able to measure KPIs consistently over time. There can't be any intervention effects where one group could influence the other, and the groups need to be relatively stable over time. K-means clustering isn't the only way to do this. You could also use things like propensity score matching or stratified sampling, but k-means clustering is a pretty powerful option when you have a rich data set. Now tell me in the comments, what experiments are you going to be running? Thanks for watching.